Hello everyone and welcome to this video. We're going to be talking today about what a register is. We're going to have a couple examples. I'm not going to explain all of them for lack of time, but the most basic function I will describe and define on those. So what is a register? A register is basically a group of flip-flops that are hooked together to hold certain aspects of data. So usually we're going to use D flip-flops in the examples that we have here. But I guess that is what a register is. Now, what do we use a register for? A register, like we said, can be used for data storage. So we can use it to store data for further use. For instance, you can hold numbers in order to add them later, subtract them later, multiply them, or even display them on a LCD, for instance, if you have that kind of programming in your circuit or your processor. Data can also be transferred. Due to the fact that it is stored, it can be transferred from one register to another without losing the data. Now let's see a couple examples of registers in order to see what they do. These are one of the more simpler ones. We have, remember in these flip-flops, each bit requires a flip-flop, and in each flip-flop, in this case, Q follows D. Of course, in the shift to the left example, you can see that the first D follows Q, but that Q follows the last D. So it's really not that complicated of an issue. It's just Q will always become what D is. So D is the first state, and then you input it, and then Q outputs that. So we put in our first input there, and now we have the most significant bit to the least significant bit, which is x0. Remember, the clock does not affect really whether it shifts from left to right. It is the hookups between the D's and the Q's here. Now let's look at this register. This register is a loadable 1-bit register in that it has an input, the DN. It has a load switch that says, do I want to load the old value, or do I want to load in the new value? If load is 0, then it's going to take that Q, which is this is the old value, the register with the old value, and it will take that and will say, okay, so that is the old value. Let's put the old value back into that register. Just keep cycling through. If it's 1, you're going to say, you know what? I kind of want this guy loaded in there, and that is going to be contained there, and it will wait for you to, it'll cycle back, and now it'll wait for you again to say, okay, do you want to load that new value back in again, or do you want to put an even newer value in? Now, once again, registers aren't the most complicated thing in the world. But they can get pretty complicated when you reach the capacity of a register file. So let's talk a little bit about that. A register file is an array, or basically kind of a string of registers together in one unit. So it can contain multiple numbers, and these numbers are going to do different things. They can be held together for math equations or for displays, as we said before. Here's an example. I couldn't really give you gate level just because this may become part of your final, and I don't want to give too much away there. But here we have a register file. We have 2 registers. Each register will hold a 4-bit, as we see from D0 to D3, it will hold a 4-bit number. And we see that the clocks are connected, and there is a write enable switch, which will allow it to be manipulated or moved or printed out on an LCD screen, or sorry, display. And those are the outputs. Now, generally a register is going to be uh, ALUs and muxes and other things are going to have registers because they also need to store data. But a register file may receive data that is stored in those functions and then be used to either be spit back into those functions, or it will be used in order to be shot to a display or just held there. For instance, if I were to have an ALU, an ALU will have a register because it needs to hold a number. In the case of multiplication or something like that, it will need to have its own register file to store data. But let's say I want to take from the ALU and I want to spit into the register a 3, let's say, and I have a 6. So I would load a 3, and I would get a 3 from the ALU, and I would add the 2, 3 with the ALU, making a 6, and then I would say, okay, you know what, I want to load the lower register with a 6, and I want to load the higher register with the same value I had before, and we'll spit that number to the ALU and add that together. 3 plus 6 would be 9, and that way you can do even multiplication if you want. You can do addition, subtraction, all through the simple use of a register file and an ALU. You would obviously need a mux for a bridge point, but that's kind of besides the point. Just remember, registers are for holding data, one flip-flop per bit. They can contain several options, including write enable. They can include a load function, an enable input function, a shift enable. And it really depends on the way that you'll design them. But just remember that what they're for is storage, and what they're used for is data transfer and storage. And that they all need to be on the same clock, and that D will follow Q in most cases. And I guess the best way to learn about them is just kind of using them and playing with them in Xilinx, which you probably won't have a ton of time for, but in the labs you will be able to learn what a register does and a register file does in your final lab. So good luck to all of you, and I hope this has been of some help. Registers are definitely going to be a useful thing in your career, whether it be in software design or hardware, whatever. So try and pay attention to this part of the course.